Hello everyone, welcome back to the channel. In today's video, we are going to understand one of the most important concept in relational function, that is bijective functions and invertible functions. Many students get confused about this one simple question: when is a function invertible? What exactly makes a function bijective? Don't worry, by the end of this video, you will clearly understand why a function must be bijective to have an inverse. We will also solve a clear example step by step so you can apply this in board exams and competitive exams confidently. So stay focused, take your notebook, and let's begin. First one, let f from n to y be a function defined as f of x is equal to 4x plus 3, where set to y set of natural number such that y is equal to 4x plus 3 for some x belongs to natural number. Show that f is invertible, find the inverse also. Okay, we have to show that any function is an inverse. First we have to show that that is a bijective function. In that, first one is 1 1. I will take a two element x1 and x2 in the domain that is a natural number in a such a way that their images are equal. F of x1 is equal to f of x2. That is an, as per the definition what they defined f of x, that is an 4x1 plus 3 equal to 4x2 plus 3. Okay, in this case 3 get cancelled. We will, next step is 4x1 is equal to 4x2. In this 4 cancel, x1 is equal to x2. What it shows that f is 1 1. When their images are equal, their pre-images also equal. Then for onto, what is an onto? For every element y in the codomain, there exists an x in domain such a way that f of x is equal to y. How the x should be? Then I defined an f of x as an 4x plus 3 equal to y. Then 4x is equal to y minus 3. Then if we simplify the 4, it will come to denominator, x is equal to y minus 3 by 4. Again this value I am going to substitute in the given definition whether the f of x will gives the y or not. F of x is equal to 4 into x. In the place of x I fill this one, y minus 3 by 4 plus 3. Then 4 get cancelled. Again y minus 3 plus 3 minus 3 plus 3 get cancelled. I got as an f of x is equal to y. From this, f is onto. F is 1 1, f is onto, then f is bijective. Then f is bijective means f inverse is exist. Then this is a function from y to n. Then f inverse of y is y minus 3 by 4, that we already find it. Okay, this is an invertible function. Let me move to the next one. Second example is that show that the function f from R2, the set of real number x lies between the -1 to +1, defined as f of x is equal to x by 1 plus modulus x, where x belongs to real number, is 1 1 and onto function. First we will move to the 1 1 function. I will take as two numbers which are in the domain that is a real number in such a way that their images are equal. F of x1 is equal to f of x2. As per the definition I wrote here, x1 by 1 plus mod x1 is equal to x2 by 1 plus mod x2. Here two cases it will come. When x1 is positive I am taking and x2 is negative I am taking. If x1 is positive means what is an output it will come? X1 by 1 plus x1 it will come. If x2 is a negative means as per the modulus definition it will come x2 by 1 minus x2 it will come. If you cross multiply and simplification you will get it as an x1 minus x1 x2 is equal to x2 plus x1 into x2. Then finally x1 minus x2 is equal to 2x1 into x2 it will come. It's not possible because x1 minus x2 is a greater than 0 as per the definition. I took x1 as a positive, x2 as a negative, then the total result will be the greater than 0. Then if you multiply the one positive, one negative, you will get a negative. It is a less than 0 it will come. The two cases x1 minus x2 is equal to the 2x1 into x2 it is not possible at all. Therefore, the rule is not satisfaction in this case. Therefore, we can't able to find whether the 1 in this case or not. Now, second case I will take is an x1 and x2 have to be either positive or negative. Both should be either positive or negative it should be. Then only we can clearly define. Now, in that first case, when x1 and x2 are both positive, such a way that I took that images are equal. F of x1 is equal to f of x2. As per the definition, it is a both are positive. Therefore, x1 by 1 plus x1 is equal to x2 by 1 plus x2. Then cross multiply x1 plus x1 into x2 is equal to x2 plus x1 into x2. x1 x2 and x1 x2 get cancelled. Finally you will get x1 is equal to x2. In the similarly if x1 and x2 both are negative you will get a x1 is equal to x2. Therefore in both the cases either both are positive either both are negative the f is 1. Okay, let's we move to the onto function. Onto, let y belongs to codomain, that is a real number in such a way that y must be lies between the -1 to 1. In the two cases when the y is negative and y is positive, if y is negative there exists an x in a such a way that y by 1 plus y that is belongs to r, such that f of x is equal to I'm going to fill the in the place of x y by 1 plus y. Then what will happen? What is the function is there? That is an x by 1 plus mod x. In the place of x I'm going to substitute y by 1 plus y plus divided by 1 by plus mod y by 1 plus y. In this case what is the y is negative. That's what will happen, y by 1 plus y 1 minus this mod become minus because y is negative. Therefore 1 minus y by 1 plus y. Then next step, y by 1 plus y I took as an 1 plus y as an LCM. Then in the numerator 1 plus y minus y, this denominator get cancelled and again minus y plus y get cancelled, y by 1 nothing but y. Therefore we show that f is onto when the y is negative. Same way when the y is positive there exists an x in such that y is equal to 1 minus y, that is belongs to domain R. I am going to prove that one in such a way that f of x is equal to f of y by 1 minus y. what I got as an x value. I'm substituting here. Again, after simplification, I'm going to prove that f of x is equal to y. Because of y is positive, here the positive only. This modulus will become positive only. After taking an LCM, then after get cancel, we will get as a y by 1, that is equal to y. In hence, in the both the case, when the y is negative, y is positive, we prove that f is onto function. Hence, f is 1 1 and onto function. Okay, let move to the next one. Last one. Let a be the set of real number except to 3 and b is a set of real number except 1. Consider the function f from a to b defined by f of x is equal to x minus 2 by x minus 3 is 1 1 and onto. We have to justify the answer. Okay na? Then first one, I will check with the 1 1. I will take a 2 number for all x1 x2 belongs to domain A in such a way that their images are equal. F of x1 is equal to f of x2. As per the definition, x1 minus 2 by x1 minus 3 is equal to x2 minus 2 by x2 minus 3. Cross multiplication, then afterwards x1 into x2, then minus 3 x1, then minus 2 x2, then minus to minus plus 2 3s are 6. In the same way we are multiplied this one, we got this one. Then x1 x2 get cancelled, 6 6 get cancelled, then minus 2 x2 I kept as it is, minus 3 x2 from the left side I took as an, so from the right side I took the left side, that is a 3 x2 minus 2 x2. Same way in the RHS, 3 x1 minus 2 x1. Finally you will get it as an x2 is equal to x1. This shows that f is 1 1 function. Same way for the onto. For every y belongs to codomain, there exists an x in the domain such a way that f of x is equal to y. In this case, we have to find as an x value how the x should be, how the pre-image should be. Then we have to verify. Then as per the definition, I took f of x as an x minus 2 by x minus 3 is equal to y. Cross multiplication, x minus 2 is equal to xy minus 3y. Then which are the x term is there, I took as a left side. X minus xy is equal to, this minus 2 will go to RHS, 2 minus 3y. Finally x I took a common from this and 1 minus y I sent to the denominator. Therefore x is equal to 2 minus 3y by 1 minus y. This x value again I am going to substitute in the given f of x. Whether f of x is equal to y or not, we will check it. Okay, then f of x value we got it, that I am going to substitute in the place of x, that is an 2 minus 3y by 1 minus y minus 2, 2 minus 3y by 1 minus y minus 3. After taking LCM, denominator will get cancelled. Then the left with the 2 minus 3y minus 2 plus 2y divided by 2 minus 3y minus 3 plus 3y. Then everything will cancel, minus y by minus 1. Then we left with the y. Therefore, f is onto function. We prove that f is 1 1 and onto function. Okay, these three are very important for the board exam. Okay, thank you so much. We will meet in the next video. Bye bye. Take care.